afternoon, everyone. I'm not as polished as Keith or Adam are, so I have a script here that I'm going to go off of, and we're going to give it a shot. So thanks for being here. My name's Cody. I'm excited to share a little bit about DEVCOM Armaments Center. I'm going to take you on a little bit of a journey today. So DEVCOM AC, or as we lovingly know it, the U.S. Army Combat Capabilities Development Command Center, Armaments Center. So trust me, everyone's happy we have an acronym for that, and we love our acronyms. So in the next couple of minutes, I'll walk you through who we are, what we do, how we're using the most advanced technology with the support of MxD, and how to make sure our warfighters have everything they need to succeed, and how important collaboration and the support of MIIs like MxD help just drive that information. So we're big in the Army about bluff, right? It's bottom line up front. So if there's anything you take away from this presentation, I'll give you the cheat sheet right now. Number one is we collaborate with everybody we can. Number two is MxD is a powerhouse of just innovation, of intelligence, of workforce, of factory floor. There's so much cool stuff to be had here. Just keep diving in. And then the third one I'm going to leave you with is how to describe digital twin to a first or second grader, because I have to do it every day. So if you leave this room with any of those three things, you can leave now if you want to. So who are we? So I want you to think of DEVCOM AC as like the gadget lab in James Bond, right? So he always went to Q's gadget lab, and there was always the coolest new stuff that he had to play with, right? The stuff in the car. So our mission is to dream up, design, and deliver all this cutting-edge technology that keeps our warfighter ahead of the game. Our vision is to be the go-to team for groundbreaking solutions that help our warfighters win every time. And at the end of the day, it's all about one thing, making sure our warfighters have what they need, when they need it, and maybe some cool toys they didn't know they need, right? So let's talk a little bit about what we didn't have when I got to DEVCOM. So I'm from industry. I walked in the door and I didn't see, we were talking about digital transformation, but there wasn't maybe the space in the room for an electrical engineer to hop in a branch of chemical engineers and start pretending to be a chemie. So this is kind of a journey through the process of helping us dissect that a little bit, and maybe you can bring that into your organization. All right, so let's talk about where all the magic happens. So our main hub is at Picatinny Arsenal in New Jersey. That's right, New Jersey. So when you think of New Jersey, you might think of Tony Soprano, the Jersey Shore, right? Or maybe an awesome bagel. But what are we really known for? So we invented C4 here. You might have also heard something called the Picatinny Rail. That's us, right? We do all that really cool stuff. We're not just about gabagool and fist pumping, right? We're about explosive innovation, literally. And we've also got some other places around here. There's Waterville Arsenal in New York, Rock Island in Illinois, which MxD has some great stuff going on there as well, and Aberdeen Proving Ground in Maryland. So across all these spots, we're running the show with over 500 buildings and more than 100 specialized labs, right? It's humbling to walk into this organization and everyone you turn around is a PhD. Like, it's the most overwhelming place to work. And these aren't your average science labs either. It's where we cook up the next big thing in armaments and munitions. And we don't do it alone, right? We've got strong partnerships with academia, with industry, thanks to the MIIs, and the armed services. We're like the Avengers of innovation, right? So if you're looking for breakthrough tech, or you just want to make something go boom, and like, who doesn't want to do that, right? We've got you covered. All right, so I kept trying to rename the D in MxD to DEVCOM, but they didn't like that. So, and we're all about acronyms in the Army, and the X and D were kind of already taken, and MxDXXD doesn't really work as far as explosives in DEVCOM. So here we are titling it Achieving Production Precision with Digital Twin, right? That's the new name of our project. So what are we really here to talk about? It's this awesome partnership, and I'm gonna get a little meta about MxD as a process, as an organization, and how they really are the rock stars of digital manufacturing, and how they helped us unleash and kind of demystify all these buzzwords, AI, digital twin. Like, we all say this so often, but like, let's stop, right? Let's say what the actual technology is instead of saying AI. And you're gonna see how they helped an industrial base that you've heard it time and time again, World War II. It's old, it needs help, it's real. So let's talk about how we got here on the project journey. So now what feels like forever ago, back in October of 2023, I stepped foot at MxD for the first time. I had my tour of the factory floor, and I saw lots of cool technology and what felt like a really cool machine shop environment. What I didn't see, though, was my blend of manufacturing. Where are the heat exchangers? Where are the pumps? Where the deafening sound of air compressors, right, and steam lines and the really bad smells of acid, man, I didn't see that. So I made it my mission to show MxD what manufacturing meant to us in the OIB. So a few months later, I had my chance. MxD came to Picatinny Arsenal for some good bagels and, all the other stuff. And we gave them the Cadillac tour, right? I showed them all the cool labs and environments, some of them very, very vintage and scary, I'm sure, as Rodrigo and Paul will tell you. We explained the challenges that we face, from data collection of the most basic sensors all the way to dispersing material in the most basic of containers. I think it was fair to say that after this, we reshaped how MxD thought about the M in their name. This is what manufacturing meant to us. So I thought I was the only one who was going to change someone's perception about something that day. It was my mission to change what manufacturing meant to them. But during the outbrief, they changed our perception of what digital twin technology meant to us. So maybe some of you have been asked the same question by leadership, right? Where's our digital twin? Or why don't we have a digital twin? Or even worse, hey, let's make a digital twin. So these are horrible questions to have to answer, right? Because the real question we should be asking is, how can I use the digital twin to help me solve a problem? Or what problems are so complex that only a digital twin can help me solve it, right? Those are the questions we should be asking. So clearly MxD was so troubled by our problems. They came home and I'm sure they were pulling their hair out like, we just have to help. They were alarmed at the state of our infrastructure and they had to partner with us to help us solve some of our really wacky, weird, and wonderful challenges. So we targeted two large things. So connecting hardware and software, right? We picked out a sensor problem. And we'll talk about that in a minute. And then we decided at the end of that sensor problem, we were gonna back it up with some really cool digital twin tech. So let's start with phase one of this problem, the sensor problem. First, I'd like to shout out, there are partners in industry that helped us concept reply, Ethan and Brad. So if you have any difficult questions or any questions at all about the, ask them, not me. They are the pros in this. So as much as I'm allowed to kind of say in this room, our processes are like making bread or getting the right consistency of oatmeal or grits, right? That's a difficult thing to quantify. Raise your hand if you've heard the term golden batch, right? It's this mythical unicorn of all the right parameters and ratios and phases of the moon and like what I had for breakfast that goes into like making the right, the perfect product. So how do we set the stage for making sure our implementation of our digital twin is as successful as possible? How do we help elevate manufacturing? So enter MxD's large members network, right? They helped us call upon, I'll call it the hive mind here, and they hosted a virtual workshop on Mount Poor. So one of the things we did in order to bridge this gap of DOW and industry was to reframe the problem. We're not mixing an explosive, we're making bread, or we're mixing a cake, right? Everybody can suddenly talk to an agitator or a mixer a little differently, and we can all have the same conversation in the room at that point. So our infrastructure didn't make this any easier, right? They also need to determine what the right sensor technology would be, if it could even pipe up to our current data layer, which was really old. Oh, and by the way, things actually go boom. So we have this hazard and classification to worry about. So there's lots of little pieces here that kind of tied into our sensor problem. So a big thanks to Concept Reply for giving us all of this awesome assistance on this portion of the project journey. So I'll talk a little bit about the sensor technology we chose at the end of this process is, one, we're putting a camera into our kettles so we can view the product. The other thing is we're using sonic velocity measurement to help us quantify that. So just to give you a little idea of where we're headed in this space. And that was critical for laying the groundwork in what is this next phase, right? So here we are, the main event, right? What everybody's come to this particular session to learn about, the digital twin. So what is a digital twin? Anybody want to take a stab at that? No, right? Great question. These were all questions that I had at some point, and everyone at every level of our organization keeps asking. So on my quest to answer these questions, I sat through some demos at large conferences like Automate, watching some big experts in the field literally build an HMI on the screen in front of me and call it a digital twin. And it said, we can't have just renamed user interface. Like, come on now. So here goes. Remember I said you're going to be able to explain it to your first or second grader, right? In short, a digital twin is defined by the experience that you have with it, right? And then I heard someone ask, would you like to talk to your data? So then I tried explaining this to my kids. And I said, all right, so a digital twin is like a magic mirror. You can pause or rewind the magic in the mirror to see what happened a moment ago. You can pretend to give yourself superpowers in the mirror without breaking the real one, right? So if you had a magic mirror for your process or a pet or a city or whatever it is, what adventures would you try with it, right? It's this, so great. We now have a definition that I can give to a first or second grade, this magic mirror, right? The second question leadership always asks after you help define them is, where's mine, right? So we started asking MxD, how do we get one? And the response we got was, cool, what problem are you trying to solve with it? And I said, well, management says I need one. But seriously, digital twin is a tool in our toolkit for helping solve extremely difficult manufacturing problems, right? And that's how we need to think about digital twin technology. Like tying the consistency of grits and oatmeal to how well it performs in the hands of a warfighter. So once again, enter the rock stars of MxD, calling upon the experts at XM Pro. Gavin, if you're still here and haven't left the room, and Nicole, thank you guys. These are the drivers of our digital twin technology. And not only are they helping us drive our learning journey through digital twin technology, but did you know that you could have generative AI drive your digital twin journey, right? And this is the really cool stuff, is it's doing all of the horsepower, the legwork of setting up our digital twin throughout this journey. We're not just using that as a tool set, but using Gen AI as the driver's seat. How many of you are doing that? Right? Thank you, Gavin. So, are you asking Gen AI the dumb questions about your process data, right? Do you have a way to open up ChatGPT for your process and say, how am I doing today? Or maybe there's a question you're too afraid to ask at the PM level, right? Or your leadership can ask it any question it wants to. This is really powerful. And are you getting intelligent answers? Can anyone in your organization with the appropriate access and controls ask any question at once in their own words, right? Like that's the end goal of digital twin technology. It is the backbone of allowing you to interact with those processes. So before I get too out of my depth out on this, Gavin and Nicole are in the back, and they can kind of walk you through if you have any more questions about how they help this World War II, level infrastructure kind of help us implement digital twins. Now we are still on the pathway of this journey. I was just too excited to have a presentation in a year that's like, here's where we got to. But we are currently going down this process, and they're helping us learn a lot and uncover our skeletons in this closet about what data we actually have versus what we thought we had. So I think I left you with two things so far. MxD are rock stars, right? And how to explain digital twin to a first grader. But collaboration, right? It's at the heart of everything we do at DEVCOM and here at the MIIs. So our areas of focus, right? If you take a look up here, and it can be easy as a white paper to get started with the government, but at DEVCOM, we wanted to point out that we collaborate with absolutely everyone to bring the warfighter the latest in technology. Before I conclude, there's my contact information if anybody wants to reach out. A big, huge thank you to the team at MxD, Rodrigo, Paul, Romina, if she's in the room at all. There you go. She makes sure that we stay on schedule, which is a huge thing for the government. I would love to take some questions.
Is the digital twin one entity, or is it a combination of different systems that you have?
It is a combination and a coordination between different systems, right? Cool. And the digital twin platform that we chose allows us to document that process. So one of the things I really like to emphasize on our journey is that there's this governance, right? And there's a bit of black box when you talk about digital twins. And that all gets dissolved with the platform we chose, is you can track, okay, I have a data stream coming in here, connecting to a generative AI request or a prompt. I've documented my prompt, I've documented the sources that I'm getting it, and here's my output from that singular prompt. And it's all documented in a single place. So it's uncovering this, the rules of governance around how are we using AI and LLMs to help drive our decisions in digital twins.
And are you using agentic interactions?
We are.
Okay.
Yeah.
Cool.
Gavin can tell you all about, he keeps trying to get me to say agentic, but I don't know enough about it yet. So I'm not going to just yet.
Cody, so thank you for presentation, great presentation. How are you thinking about the value, right? So a lot of us are from commercial industry, right? So it's essentially dollars saved, the incremental revenue. But how do you come to define the value of whichever project you do, whether it's digital twin project, like data unification project, et cetera, et cetera? Because there got to be some other key value drivers for you that are not accessible for commercial business?
So two things. The first is, and great questions, the first is transfer of knowledge, right? If you go out to the OIB, there are people who literally can look at a product and tell you it's done. They can taste a product and tell you it's done. That's scary as that is. And I'm working on demystifying that, right? Like bringing in the right technology to do so. That's how sensors solve the problem. For us, digital twin technology is about speed. We need to be able to go from developing a new formulation at the lab scale, putting it into our pilot processes, and then being able to transition that to production in less time than it takes now. My lag time is 10 years. I've got to shorten that up by a lot. We understand our production processes really well. Defect rate, certainly, and reducing scrap are important, but for us, it is about getting this technology into the hands of the warfighter faster.
Got another one on this side.
So you had said, choosing the right platform. And I'm wondering a little bit more about that process. And you may have just touched on it, that it's about, what value you're trying to create. But what was that process? So let's say, a company that's not in defense like yourself, that what is the process? What should they be asking of the company they're working with to develop that? Or if it's in-house, how do they start? Can you mention, say anything about that?
Sure. So we relied really heavily on MxD for this one. When we went out for, asking around, well, what's the right digital twin ecosystem for us to use? Like, what is it we're trying to do? We evaluated lots of different options, and we have a lot of different digital twin technologies. For this one, we just so happen to be using one that has founded the Digital Twin Consortium, which we thought was extremely important. At the end of this process, we will receive a framework that helps us lift up our other partners in the other services. So we've got Navy here, right? And we want to be able to be those, the Q's Gadget Lab, those technology champions that if someone needs help and they want to implement a digital twin, they're not restarting the process. Hey, DEVCOM, you guys know how to do this, and you gave us a guide to do so.
Good afternoon. Just curious, when you brought in devices to monitor, correct, into maybe an older factory. Is that a fair statement?
Yeah. That's being kind, yeah.
Okay. What was the connectivity that you used? Was it a wired connectivity to the devices, or did you use a wireless connectivity? Just curious about that.
It's all wired connectivity.
All wired?
Yeah. Wireless is not a great implementation for us around energetic materials.
Okay. Why would it not be a great implementation for you? When you think of what?
There's just a lot of cybersecurity issues around wireless, right? Our industrial bases are air-gapped, so we tend to be a hardwired connectivity location.
Okay. Thank you.
No problem.
Thanks. So
curious on how you've got a lot of data, right? You're trying to collect in this model of, and just talking about security, how are you figuring out where the data is allowed to live? You know, how to build these things out. I mean, one of the things we're running into is, okay, I have a model. My data isn't as quite as secure as probably what you're dealing with, but we're still struggling with, okay, the contractor developed the outline. How do I get it onto a system where I can run it? It's a huge hurdle to get to play with it and actually make it happen. So curious as to how you're solving that problem.
So remember we talked about the bakery scenario, right? Or being able to say this is something that's applicable to modern industry that's not sensitive and classified. I can stand up that instance in a cloud because none of it has anything to do with explosives, right? We can work on the pieces that we need in a public environment. And then as soon as we need to involve something like actual data, right, we can bring that into our enclave. And only we have that access to it at that point. If contractors need to, we have methods for bringing in contractors to do so. But it's being able to have that hive mind and that groupthink on something that is not so sensitive and solve the problem there, and then bring it in when we need to. It's a different approach, but thank you.